Um, Welcome to this session on Ballerina, the cloud native and DevOps friendly programming language. Um, so here I'll be talking about the Ballerina language and how it's suitable for cloud native development, and also how it's helping the DevOps operations as well. So to start with, if you look through the history, we have seen that when we have with the new requirements, when the applications become more complex, uh, the the architectures tends to go to like they tend to increasingly disaggregate their architectures. So that means they are splitting up their components and organizing in that way to handle the requirements and things like scalability, reusability, and so on. So when you do this disaggregation, it naturally leads to more endpoints. So when you disaggregate through network boundaries, that means all the functionality is exposed through network endpoints. So this leads to more and more network endpoints, and this is increasing exponentially. So when you have a lot of endpoints like that, um, so you need to make sure that these endpoints and the communication is handled properly, because with this with all of these endpoints, the distributed systems will get like a lot of other issues like transaction handling, uh, communication resiliency, protocols, data formats, and so on. You have to handle all of these properly. So this is where Ballerina comes into play. So it is an agile, network-aware programming language. So the idea of the language is to basically uh, have some of these uh, high-level abstractions in the language itself. Sorry, for distributed computing, and also to have the flexibility you get with a general purpose language. So let's see how we have basically done that using a programming language. I'll be quickly going through the language features. I'll start with the basics and gradually build a small scenario with that, and I'll be doing some live coding to show how it all works, and doing some deployment operations to show the whole end-to-end process. So let's start with the customary hello world. I'll quickly show how the development is done. So for Ballerina, there is a VS Code plugin that you can install and use. I'll quickly create a new file. So it ends with the .bal extension. So I'll create a service. It's like a hello world service. So we can have like main functions as well. Also, in Ballerina, there's a separate entry point uh, for services. So a service is a first class concept in the language itself. So let's say like my service is hello. I have a resource called hi, and I'm just going to simply turn a response. So there's some error handling required here. I'm just going to say okay. So that's it for a simple service. You can see here, I didn't have to like import any special, like add a special dependency to the program or anything. I just have a service and a HTTP type service in that case, and I can quickly uh, create something like this. So let me run this, I just have to say Ballerina run .bell. Okay, now my service is running. Now we can quickly send a request to this. I just say hello, hi. Yeah, so you can see we basically sent a request to that service and we got a response back. So that's basically how a basic Ballerina service works. So this is what we did. Like we did a get, we got a response, a hello world, and we can uh, basically augment the behavior of the service with annotations as well for the service. So let's say we are going to change this to a post request rather than doing a get, and change some of the contexts that are there. So we can simply say, okay, the methods I'm going to support is only post. I'm going to limit it to post, and I'm going to actually read in the input from the user and use it somehow. So let's say okay, I expect a text payload, and so I'm just going to use it in my response. So let's say okay, so this taint processing is we call it taint analysis. It's a security feature in the language. We should do some static analysis in the code to track some of the data that may be tainted, as we say, like network input, program input from the command line, anything like that are considered tainted. So we have to validate them specially and put these directives to say that it is okay. So this is it basically for changing the request. Let's say we want to change the base part of this also, and change the base part of this to say just okay, just call it hello. So now let's run it again. Okay, now we can just send a post request to this. I'll just use curl for this. Yeah, so you saw now it's just taking the post data and just returning back with saying hello, the data we sent. So that's how you can like easily change the behavior of the service using these annotations there. So the other thing is the use of like network connectors in the language. So in Ballerina, so we have a special attention. We have given special attention to the network aspect and how we handle these network operations and so on. So the client, sorry, so the client network connectors and listeners are like special again like concepts in the language. So those are like understood by the language and how they behave and so on. So as I will show you, that ties up with the built-in observability and other optimizations that we have in the language. I'll quickly start with another demo where I use another network connector. So here I'll be using an Amazon recognition connector and doing a simple operation. where I pass in some image data and get the text there detected and send it back. So basically, I'll use that scenario as the base for the other scenarios I'll be demonstrating. So let me quickly start a new file. Let's call it demo.bal. Yeah. So for this, I'll be using the Amazon connector, and so again, we'll be having a HTTP service for this. Just call it. And I'll create the configuration needed for the configuration, the Amazon recognition configuration. So basically, that's the configuration I needed for to initialize the client connector. So I'll be basically reading some API keys required to use this connector. That can be either from our own variables or from a configuration file. And now I'll actually clear the client. Okay. So now I simply have to read in the user's data here. So from the request, just get the binary payload. Do some error handling here. Now let's see what are the actions we have or the remote methods we have in our connector. We'll be using this detect text, and we will be just giving the byte array which represents the binary data. And from that, we'll be returning either a string or an error. So in Ballerina, we have a union type support in its type system. So we can create new types based on existing types, where you can create unions. That means create that type using a union of a existing set of types. So here, what it's returning is a string or an error. So it can be the value can be of either type. So if I say like this, so then I had to then I had to actually check the type. If it's a string, okay, then fine, I can use it, or else it's an error. So here, if it's a string, I'll basically be returning that back to the user. close. I'll just give it as an error message. So basically, that's it for our code. Let's run it and see. Okay, so the service is up. So the data I'll be sending is this image basically. So which should detect the text there and give us the response. So let's run it here. And I'll just quickly get I'll quickly update the base path in this in our service actually, so it's easier. Just call it process. Oops. And this port there. Okay. So let's just run this. Okay, so you can see we got the response back. So this basically goes through the data goes to our service and it contacts the remote Amazon service and returns back the response. Also, another unique thing about Ballerina is all the code we write is by default visualized as a sequence diagram. So the language is designed in that way. Basically, all the concepts and the code and the remote operations and everything is compatible with this model. So if you notice earlier, the client operations I did, like this detect text, is with this arrow notation. Basically means it's a remote operation, a network operation in relation to the language. So it has it can separately understand that I'm doing a remote operation like this. And also, especially with this diagram, it shows that with as a message passed through to the remote endpoint. So we can nicely visualize it like that. Especially when you have complicated scenarios, you can have a quick glance at it and see what are the interactions happening between different actors in the system, and so on. So this becomes very convenient, basically, when you develop something. So it's basically um, self-documenting code, if I say so, like what you are doing with this diagram generation. So moving on. So now since we have the base sample that we'll be working on, so let's check on the Docker and Kubernetes support we have in the language. So in order to give more power to the developer, as with DevOps, we have like a very convenient integration with Docker and Kubernetes in the language itself. So as I will show you again with a simple annotation method, we can make our services quickly deploy to a Kubernetes environment. So let me show how that is done. So let's take the earlier service. So what you simply need to do is uh, use the Kubernetes module. So So you have an annotation called the Kubernetes deployment. So this is the main annotation you need to make your service deployable into Kubernetes. So it basically helps with the deployment artifact generation. Doesn't change the code in any way, the actual executing binary. So in the deployment, and in our case, we also need to signal to Kubernetes that we will be exposing this application as a Kubernetes service. So we can give extended information about that. For example, I can say, okay, my service type would be either node pod or load balancer, and so on. So I'll be using load balancer here. And I can also say I want to expose this in port 80 and so on. Another thing I may need is uh, a config map. So I actually have some configurations that I'm using. So I want to bundle that also with my deployment. So I'm giving that as well. So currently I have these configurations inside a file called Ballerina config. So I'm just telling the system to get the attributes of that and create a config map out of that. So these will be available when we are deploying there. So the Kubernetes deployment, there are some additional attributes required in my case. So I'll just put those in here. So it basically, I don't need this part. So it basically says, you can give like things like image, the Docker image, name, the location. And here I'm looking basically Docker Hub to push my Docker image to. So I'm giving my credentials here as environment variables. So this is just required at the deployment time, as in when you're actually building the application, as I will show you. So this is basically what you need. And let's see how to basically go to the next step. So in this case, I'll be using the Ballerina build command. So the only difference in build is earlier the run command build and ran in the same command. So it compiles and runs same way. But here I'm going to do it in a two-step. I'm going to build it first and then run it. So when you are building it now, you can see some additional logs saying, okay, it's processing these Kubernetes annotations and so on. So these are basically compile extensions that are there. Even you can write your own extension and plug it in, which gets invoked when we actually run the compiler. So the Kubernetes extension, the compile extension, basically looks at the code and automatically creates a Docker image, push it to the registry, and also it generates the Kubernetes artifacts automatically. So you can see here, so we just have to run this command that's given by the compiler at the end. So I'll show you currently my Kubernetes cluster doesn't have any pods, anything running. It's currently pointed to a Azure Kubernetes service, AKS cluster basically. So I'll be using that. So let's simply run this command and see what happens. So it got deployed, and let's see all the services that are there. So we have a service deployed, the Kubernetes service. The external IP is pending. It'll take a little bit of time for them to create and assign an external IP for me. So then I can use that to, it came pretty quickly, to call that from here. So basically now the service is deployed to the internet. I should be able to access it from here. So let's update our endpoint here and see how it will go. first time it may take a little bit of time because for it to warm up and to actually get the request going there. Yeah, so we saw now like it has gone and we got the response back. So we can run it again and see. Yeah, so that's how it works. So we saw how like quickly we got the service running and add some annotations, and we can easily get things deployed to actual Kubernetes cluster anywhere that you have. So it doesn't matter it's AKS or it's Amazon or Google, any Kubernetes cluster, it would be the exact same operations you would need. So it'll work in any cloud service provider. So you saw these things, the options in so the Kubernetes, we can configure all the possible options here, like other things like secrets, ingress, and so on. So all the things are possible. Let's quickly check the AWS Lambda support also we have. So similar to so the Kubernetes support in Ballerina, so you can take a simple function and turn it to a Lambda as well. So you just have to put a simple annotation again, and you can directly deploy it to AWS Lambda without any other further steps to do the deployment. So I'll come back to this scenario again where I'll be demonstrating some GitHub Actions features also. So yeah, actually can show it here itself. So now we saw like, okay, this is how you write some services or like some serverless function in Ballerina. So now at the time of deployment, okay, how do you do some CI/CD? So GitHub Actions so is an rather a new way of doing things. So we have a Ballerina action also implemented for this. So you can easily bind your CI/CD operations to GitHub itself and get things done easily. So I'll quickly show you how that works. So the workflow will be something similar to this in GitHub Actions. So in your repo, you will have a workflow file or multiple workflow files that gets triggered into with a certain event, like on a Git push or a release you do with a repo and so on. So you can have for continuous integration for every commit or push, you can have the code build and the test run, and also for delivery. So when you cut a release, you can say, okay, I'm actually going to deploy this somewhere. It can be like a Kubernetes cluster or a serverless function in AWS Lambda and so on. Can be anywhere. So all this can be defined in a workflow here in GitHub Actions. So let me quickly show you a simple GitHub Lambda and a GitHub Actions indication. So I already have a simple sample, my repo. Let me go this one. Okay, this one. So it's a sample with Lambda support basically. So what happens is, so this okay, I hope you can see it. So this is basically, oops. So this is basically the code. And so I'll quickly show what happens when you build a code with Lambda. So when you build something like that, it'll again create the artifacts required for you to deploy it to the certain environment. So here the Lambda, and gives you the commands that you need to execute to actually do the deployment. So you have to just fill in some placeholder values like your Lambda role ARN that will be there in your AWS account, the function name that you get. So we list out all the functions that are there, and you just run this command and deploy it. That's it, and it will be directly available to be invoked. So in this scenario, so I just have a simple hello world, and I already have this deployed. So if I want to execute it, I can just say and invoke function name hello. The output file is this. I just cat that file. Yeah, so you see hello world comes out. So what I'm going to do is I'm going to simply edit this here, and so there's a okay. I'll actually first show the workflow I have written for this. For the deploy, so for each push, I'm actually going to deploy this to Lambda. So in the workflow, I'm going to build it using the Ballerina action. And I'm going to use another action to actually deploy it to AWS. It's a AWS CLI action. And you can provide all your secrets and everything that's required in the GitHub, in your GitHub repo settings. So I'm giving the AWS secret key and the access key ID required to do the deployment. So this is it. So you build it, and the artifacts you generate is used by the other action. As simple as that. So let's see what happens when you edit the code. So it should execute the workflow and deploy again. I'm just okay. Hello, John. I will directly commit it from here. So now the code is updated. Let's see actions on what will happen. It's already scheduled to be executed. So it will take a little, do some preparations, and it's executing the action. So till this is happening, I'll explain. So the actions can be used in various scenarios in Ballerina. So Lambda is one scenario, and also as I mentioned earlier, we have the scenario where I can directly deploy it to a Kubernetes cluster also. So using by providing the kube config and everything in your configuration, you can automate that process also fully. So I have a sample here also, which I'll put it in the notes, where according to the changes you do with the release or anything like that, you can directly push it to a Kubernetes cluster and make it run like that. And the other one is also in Ballerina, we have a module repository system called Ballerina Central. So it's a centralized module repository where anyone can upload their modules and others can reuse them. So that operation also can be connected to GitHub Actions, where when you just do a commit or a release, we can directly deploy to Ballerina Central. So our process is done. So ideally, it should be deployed now. Let's execute this and see. So it's the first request after some time. Okay. Now you can see now our Lambda is updated with the code. So we can see here how easily we can do those operations for CCID operation with GitHub Actions and Ballerina support that we have for that. Makes it easy to use those environments. Let's quickly move on to the observability part. So in Ballerina, another basic philosophy we have is whatever that can be observed by default, we do that without lesser intervention from the developer. We are having like good defaults on things that can be monitored automatically, especially with the network awareness. We can monitor a lot of stuff that's happening in a Ballerina program. So I'll quickly show you how we can monitor the earlier scenario we implemented. So basically we have support for metrics, basically metrics and tracing in build. I'll show you how that can be quickly done. So I'll just run some Docker containers for Prometheus and Grafana, and actually Jaeger also for the distributed tracing. So that's Prometheus, that's in Grafana, and this is Jaeger for distributed tracing. And our earlier so let's run our earlier program with observability enabled. By default, it's disabled, but we can globally enable it again. Just say likewise. So now we see we get some additional endpoints for Prometheus to connect to the application and so on to get the metrics. Now let's actually put some sample requests in to get some stats out. Okay, now let's go and see, basically check Grafana to see to configure it and see the stats. Okay, let's quickly add a Prometheus data source. So the data source is at the IP. You'll get the external IP. Okay, the data source is added. Let's import a dashboard. We have an inbuilt dashboard for Ballerina. Okay. So yeah, so we can see the requests that were made earlier, so that were collected. So you can see the stats here, and there are a lot of interesting stats available here for the throughput, the error statuses, and everything. So of course you can customize this dashboard also as you see fit. And so these are for the metrics. Let's quickly check on the distributed tracing also. So we have Jaeger here. So let's select the service and find the tracers that are there. Tracers for the 3 requests I made just earlier. So we can see here the operations I have done. So I did only a few here, from the input request to the detect text, external request goes out, and the thing that goes back out to the caller here. So for each step, we can see the stats and how it behaves. So all of these are done without any manual intervention. So this is just done from the system itself. because it knows that the operation I'm doing, and it can track those. So that's it for basically the observability features. Also, we have OpenAPI support for services. We have to define OpenAPI is basically earlier Swagger 2.0. So you can define your service using this, create stubs, clients, and so on in Ballerina. So sequence diagrammatic, I explained that earlier, where the language itself is built on top of this concept, and everything you do, all the program to write, will be visualized as a sequence diagram. So there are a lot of other related integrations that are there, especially to make your development and the deployment easier. So I showed you now Docker Kubernetes, Lambda. So we also have Knative support and Istio and so on for service measures. A lot of other environments, connectors, and so on that are there to make this end-to-end operation easier as much as for the developer. So that's basically it for my session. So this is an open source project, the Ballerina. So if you can get involved in the project, or also you can query for support. Like we have a Slack channel, and we have some mailing list also that you can join to give new ideas and help with any features maybe also. So that's always welcome. So the demo code I just did can be found in this link. So please go and try it out. And yeah, any feedback is welcome. Thank you. So if you have any questions, I'm not sure whether you can send me questions through this, or else just send me the questions later, and I'll get back to you guys. Thank you.